In a world where Starship technology is dreamed of, the question remains, how would we recognize it if we saw it? The YouTube channel of Perspectives Enhancement Project POV Gateway presents the Giza Advanced Science Project, or GASP, with today's focus on the Great Giza Pyramid, Khufu. POV Gateway does not at this time address who built Khufu nor how Khufu was constructed. Although these are relevant concerns, they are not germane in answering this primary GASP question of what, if anything, is the original equipment manufacturer design, the OEM design, of the Great Giza Pyramid Khufu capable. This GASP investigative report is a work in progress exploring the scientifically logically possible MHD functionality of the design features displayed by the pyramid structure Khufu. The Giza Advanced Science Project is not a mission of archeological restoration. The GASP mission is to consider Khufu as an MHD-oriented apparatus that is partially disassembled and in disrepair. GASP's intent is, by reverse engineering Khufu, to a. create a virtual type apparatus from applying Khufu design factors now present, b. to replace the MHD-oriented missing components that seem the best fit for the actual OEM components, and c. formulate a virtual MHD apparatus and run operational simulations to replicate Khufu's projected OEM design functionality. The reverse engineering process is to reproduce a manufactured product following detailed examination of the configuration and/or composition of that manufactured product. After more than a decade of research and reverse engineering, the authors of the POV Gateway, William Johnson and Samuel Cox, have discovered that the current results of such a detailed examination of the now remaining physical evidence of Khufu Pyramid declares the Khufu OEM design is a systematic MagnetoHydroDynamic plasma processing facility. The Great Giza Pyramid Khufu's OEM design is consistent with a combination of MHD operations integrated into an extraordinary hydraulic control system of very advanced design that automatically generates, modifies, and distributes plasma products called plasmoids, which are magnetic bubbles filled with ionized plasma, an expected hydrogen chloride gas, and from this plasma, further processing formulates the plasmoids, these being magnetic entities of plasma held inside a magnetic bubble. Defining basic magnetohydrodynamics. The basic magnetohydrodynamic system involves an electrically conducting fluid such as plasma, liquid metal, or salt water that moves through a magnetic field, and this combination produces the transformation of thermal energy and kinetic energy into electricity. MHD operations in astrophysics. MHD is observed in large-scale, low-frequency magnetic fields in astrophysics. Examples include the interstellar medium, such as galaxies, solar flares, stellar winds, coronal mass ejections, and the formation of jets from black holes. MHD operations in geophysics. Earth's physical interconnected solar-terrestrial relationship creates Earth's global electric circuit by way of Earth's electromagnetic field structure, containing the fluid dynamics of the saltwater electric conducting fluid of its oceans and atmosphere moving through it, resulting in global weather system. MHD operations in a manufactured apparatus in laboratory applications in engineering, such as the electromagnetic conduction pump. An electromagnetic conduction pump is a device that moves electrically conductive liquids, like liquid metals or salt water, by applying a magnetic field perpendicular to the flow direction of the conducting fluid, while simultaneously passing an electric current through the conducting fluid, which generates the Lorentz force that propels the conducting fluid. An electromagnetic conduction pump is a type of pump that uses electromagnetic forces, the Lorentz force, to propel conductive fluids by way of a hydraulic control system component conduit called a flume that can be a cylindrical tube or four-sided tube or a three-sided trough shape to contain and transport the conducting fluid.
Here I have a relatively modest strength N40 magnet, and on either side I have 2 nickel electrodes. What I'm going to do is I'm going to fill this container with water. Very pure distilled water is a very poor conductor. Thus, we can enhance the conductivity if we add to the water salt, regular sodium chloride, table salt. Salts have a very low ionic bond strength, and so when the positive sodiums and the negative chlorides are exposed to the very polar water molecules, the water molecules will intersperse and cause the positive and the negative ions to separate from each other and flow around inside of the medium in which we've placed them. So if I put that in there, and let me get a little stirrer, these ions can do the same thing that the electrons do. They're much more massive, and there's far fewer of them, and so an ionized water, like salt water or seawater, conducts electricity, but not very well. So we need to use a fairly high voltage to cause any significant current to move between these electrodes. So as this salt is dissolving, I'm going to attach 2 leads from this power supply to the electrodes. What I'm going to do is I'm going to place a little dye in between the electrodes, just so that you can visualize what's going on a little better. And there's a couple of YouTube videos out there that show this. It's kind of a neat little phenomenon. Hopefully it's not flowing too fast right now. Maybe a little bit. Give it a little bit of time. Okay, not much. Now, if I take the power supply and I apply a voltage, what will happen is as the voltage goes up, we start to generate a current, which you'll see over here, and the current will cause the dye to flow. Now, if I take my little Q-tip, my little toothpick, and enhance that a little bit, you'll see it's streaming. Kind of neat, huh? Now, if I turn the voltage up a little bit higher, you can see the flow is pretty impressive. Nevertheless, the force that's being generated is proportional to the current, which right now is about 0.3 amps, and to the magnetic field. So what happens if we get a little stronger magnet and a much stronger field? Okay, so now what I've done is I've replaced this apparatus with a new one. And in this case, instead of using an N40 magnet, I'm using an N52 magnet. The number at the end represents the strength of the magnet. This is a much stronger magnet. In addition, you'll notice that the channel width is only half as great. As a result, the current flow is proportional to the contact area of the liquid across the electrodes, but also proportional to the distance that the current has to flow. Making it narrower means that for a given voltage drop, we're going to get more current across here. And as a consequence, we'll get much higher flows from this apparatus, as I'll demonstrate. So when I start to turn up the current here, the voltage, you'll notice that you get pretty darn significant flow. We're up at 3.5 amps when we were only generating about 0.3 amps before. In addition, you'll notice this foam that's forming here. And this is the hydrolysis of water that occurs when you get over a potential between the electrodes of 1.2 volts. The electrical potential is actually disassociating the hydrogen and the oxygen, and those bubbles are the foam of the hydrogen and oxygen being released. Now, as I said before, a generator and a motor are basically two viewpoints of the same process. And so this process can be inverted, and we can use this process to generate electricity. Let me show you that.
Demonstration of feeding conducting fluid into a downhill flume by gravity in the subterranean chamber at the west wall and the Grand Gallery central floor flume, generating additional voltage and ions to run the klystron of the Queen complex and the Van de Graaff generator at the ceiling of the Grand Gallery and its charge collector atop the King chamber.
All right, now what I've done is I've taken the same salt water, I've placed it in this little burette. What I'm going to do is I'm going to open up the valve and we're going to flow the liquid, and you'll see the voltage here that occurs when we start a flow of the ionic liquid past the magnetic field. Now, as you notice, it's not a lot, but nevertheless, it does show that there is some potential. And the reason that the voltage is so low is simply because we have very little velocity here, and we don't have a very large surface area and a very weak magnet, but 56 millivolts are being generated by this system. In order to get real power out of this, we would have to flow the fluid much faster, and we would want the gap to be much smaller, and the magnetic field, if possible, much stronger.